Sorry.
Hello, Midnight Coders, and step inside the igloo. Coffee is on. Pour yourself a cup and have a seat. In tonight's episode, Hayden and I are chatting with our guest, Andrew, aka Override, a developer who is studying compilers and languages. So, Override, can you tell us a little bit about yourself?
Yeah, so I started programming about 3 years ago. I'm from Massachusetts, by the way, and I started studying it at university, where I fell in love with compilers. I started with Java as my first language. Shout out Java. And it was actually funny because we used JGrasp as the IDE, so a lot of the times when we were programming, we had to really debug a lot of the stuff. And we were writing code by hand. So I really got the appreciation for compilers and stuff. But yeah, just been studying it for about 3 years and been really loving the journey.
Now, if you could write your own language, what would it be? Would it be functional? Would it be object oriented, or maybe a scripting language? What would be your dream language?
I think it would be a multi-paradigm, but I would focus more on functional. I do like object-oriented. It has its purposes, just as functional languages have their purposes as well. But I find that multi-paradigm languages definitely statically typed, for sure, and preferably strongly typed as well. Um, but yeah, multi-paradigm for sure.
Hmm.
I really like that, dude. Um, wh- so when you say you want a statically typed but functional language, multi paradigm, Java kind of encompasses that, right? Like we have lambdas in Java, which are a functional
Interface.
property. Right, well, I mean, they use interface under the hood, right? But the lambda comes from functional programming. Like the way that they implement it is with anonymous classes, etc. But what I want to hear is like why do you prefer functional languages over, let's say, C or like why do you like functional languages?
So I mean, I just find, um, I mean, first off, I think that Java's great, right? And I think that the Lambda is a pretty good solution for functional programming. However, it does have some problems, obviously, like some scoping issues. I don't inherently, I haven't ran into in some particular scoping issues, but I do know of some that I've read about, with just like, you know, because when you add functional programming into the I guess you could say plate, it now becomes a situation where you're dealing with immutable objects. So what does that mean compared to something object oriented with a class where you have mutability and you have state? Uh, and basically, you create a constant variable. uh it can be tricky to wrap your mind around like what that means, and how you can only have that one instance of that particular variable, and it can't really change over time. So it's always going to be that one thing. And that's the beauty of functional programming, because it allows you to really nitpick on where the problem exists.
Yeah.
And I think that functionally, speaking, it also relates heavily to mathematics. And I've found that, the stuff that I've been learning with math, like recursion, that's heavily used in functional programming, but it's used within mathematics as well, like proofs. If you think about what induction is essentially recursion, but it's instead of, you know, going down or to something, you're starting at one and then you're doing k plus one all the way up to wherever you need to go. That's essentially recursion, right? And so I just find that it's pretty much close to mathematics, and I've found with my academic studies that it's just beautiful what we can do computationally with one sort of paradigm and another paradigm. And it's crazy what you could achieve with both languages.
I love that you pointed out the contradiction in Java with the immutability. Like all Java objects are immutable, but we have the final keyword, which you would assume would make it immutable, but it's just the reference that is immutable, not the actual object itself. So you
Mm.
would love like full immutability.
Yeah, I think that it's I prefer it because I prefer just composition over inheritance. I mean, I prefer being able to compose these objects and being able to do it in a more functional approach because I would, in my mind, I would just say, hey, if I'm going to do something with data, I would just create a function for it and pass that data set through the function and have that function do something with that data, essentially destructuring that object. You know, how other languages like TypeScript and all that. I really like language, I know this is more catered to Java, but you know, I've been using TypeScript for a little bit lately, and I have really appreciated some of the things that JavaScript, I guess, created. I don't know. There are some beauties that lies beneath a lot of languages. Java has some beautiful things, and TypeScript has its beautiful things as well.
Scripts is a
Absolutely.
rapper.
Would you say
Yeah,
that
yeah.
TypeScript is your favorite language?
No, 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 no.
What
I
is your
don't.
favorite language?
I don't really have a favorite language, I guess. OCaml, I guess, is probably a language I've really been interested in. Um, and I've been enjoying it a lot lately. I do want to do more work in it and program more in OCaml. But I've sadly had to use, not sadly, but I've had to use Java and other languages because of school and stuff. But yeah.
Don't hate on Java too much, dude. That's my
No,
harsh.
no, no.
If you had your dream language, or like a mixture of features from every language, what would that look like?
Man, that's a tough question. It's a good question though. I really enjoy I really enjoy some things from, like I was saying, TypeScript destructuring. I do enjoy some things also from Rust. Like I mean, well, OCaml has amazing pattern matching, which is something I think all languages should adopt. Pattern matching is phenomenal, and I know that has their type of
They're getting
pattern
better.
matching, but it's nowhere near these other languages. But I do think that a lot of languages have great. I like the way that Java does lambdas, for instance, right? And I like the way that Java represents data. Um, like I like the way how you would do a generic in Java, and it's essentially the same way, like how you would have array of type some structure in the diamond braces, and a lot of people don't like that, but I really enjoy that. I think that's a great thing that Java did structurally for their types. Um, I don't know how you guys feel about that, but I like doing the int as type and then the name as well. Like I don't really like doing the name colon type. I like doing the type first. You
Oh,
know,
I'm a var user. I like my var.
That's the
like
exact reason I do not like Kotlin. Kotlin does name and then type instead of type and then name. I think it's much more readable when you know what the type is, because the type should explain what it's going to do.
right, right. Yeah, and I think even with functions as well, this is what I will say. So there is, I can code it in real quick, but there is, if you can look in the chat, there is a way that like JavaScript handles and TypeScript, the way that they handle functions, like they do it in two different ways. Obviously you can do it the generic way where you have a function foo, and then it just returns whatever. We'll just do empty for now. But I think that, JavaScript really put the pin on the head on how functions relate to math, honestly. Like you would do const foo and then equals the function, and then you would say whatever. I think, and a lot of people, if you want to look at that, sorry, there you go. It's in the chat. But a lot of people don't necessarily like the second way, but I think that that's a fantastic way because that is pretty much how functional languages do it as well, where it's passed by that's using first class functions. So you can essentially just pass a function as a variable.
Right. Is there any way to reference the former as a variable with some sort of like method reference like they do in Java?
I'm sorry, could you say that again?
So with the former, function foo, and then you return the variable as opposed to initializing a lambda and then returning the variable. Is there a
Right.
way to pass that function as a variable, or is it only with the latter?
Um, I don't think I understand your question completely, but if I do, are you saying basically the
So
way?
with the second one, right, where you put that method in a constant, you can then pass that method as a parameter to another function, right?
Right.
Now, are you able to do that with the first one? Function foo return empty string?
Yeah, you could definitely say like, const something equals that function. Yeah. Yeah, and you can have it.
Oh, okay. So then semantically, what's the difference? And why should you use one or over the other?
Well, I just think personally for me, like those who have like mathematical, not I'm not saying I have a mathematical background, but I'm very much into math. And I'm getting more into math and that structure, how const foo equals some bracket, that is more related to how like the lambda calculus would do it. And
Oh,
yeah, so it's
it
it's
looks more natural to you.
it's more natural to how we would think of like so if we talk about computability we have like the lambda calculus and we also have Turing machines, we the Church Turing thesis, and so basically it's just crazy how this structure is very similar, and it's yes, to answer your question in short, yes, it's very similar to how it is structurally done in mathematics.
I had to snag
Right
a
on.
picture of that so I could throw it up on the screen so other people could see it.
Yeah, the second way is definitely, I'm a fan, 100%.
Now, um, so we talked about this prior to the podcast, but I wanted to sneak some Java facts and some demonstrations into you guys. Um, some things that you might not know. I got a lot. I got a lot to share, and I'm gonna kind of throw them in here and there, like during our conversations.
Oh,
And
oh,
this is by no means a segue because we had an awkward pause. It had nothing to do with that at all. Um, but I would like to share a Java fact with you guys.
Okay.
So I didn't know this until Googling this today. I had no idea. Python, the language, is older than Java.
yep, I knew that.
I did
Yeah.
not know that. I did not know that. So points to you because holy shit.
Did you
How
know that?
come Python? Yep.
Did you know that the double equals does not work on all integers?
Oh, can you explain?
So,
What? What?
okay.
Huh?
So here in my IDE, let me zoom this in. So if you have integer a and integer b that are equal to 100 each, and as you see here, if you compare a equals b, it's going to come out true. But if you have an x of 200 and a y of 200 and try to compare the two, they do not equal the same.
Right. I'm still loading your screen. I'm not able to see the stream in real time. Just give me one moment.
Oh, sorry.
Would you be able to share your stream on Discord?
Uh,
I
let me
see,
get
I see, I see.
let me get there. Share my screen. This will probably screw people up on the stream, but all right. So
Okay.
yeah. if we run this code,
Oh yes,
if we
yes.
straight up run
So
that code, it
I can actually explain this a little bit.
I was gonna
So
I was gonna ask you if you could explain that before I like reveal it.
yes, so because you're not using primitive types, these are objects. These are allocated spaces in memory. And when you use double equals, it's looking for identity, right? And because they're objects, they don't share the same space in memory. They're not in the integer cache, right? These are their own objects that are allocated outside of the integer cache. Maybe once you call them, it will refer to the integer cache. However, these are objects allocated in memory. So when you check the identity of x is equal to y, it's not the same because with literals, it's the same space in memory, but with objects, they're allocated in different spaces.
Sounds good to me.
If I had to use a smaller number, it would have been true.
What do you mean? What?
Your
What?
integer caching only goes for what's technically negative 128 to 127.
No way. What?
It's because it's unsigned.
I
So
did not know that.
yep, I didn't know that until today. To be about half an hour before this podcast, it blew my mind.
That's crazy. Oh, another fun fact. This is not on my notes, by the way. You can actually, with reflection, change the integer cache pool. And so then when you literally declare variables to be unboxed into an integer object, it could not match what you assigned it to. So if I had like integer a is equal to 50, and then with reflection I changed the instance in the pool that should have been filled with 50, it could yield you something like -4.
Hmm.
I would actually I'll demonstrate that to you later.
Okay. Did you know that the
And
transactional annotation inside of Spring does not work if you have the private variable? If
what
you're
is the transactional
so
annotation?
if your method is marked as private, transactional does not work. Transactional, the purpose behind that is if anything in the chain fails, everything is rolled back and nothing was technically done. It's a way to assure that data is fully processed, and it's typically done when writing data to a database, modifying data to a database, just to ensure that things are done. Forget the word, but more or less to make sure things that are not that make sure nothing. So, like if you were to go through a banking transaction, so you need to withdraw money from my account, make sure it's there, add money to your account. But let's say it took the money from my account, but it couldn't add it to your account. Well, without a transactional phase, it just goes right there. You never got the money. I'm now out of money. But whereas if it's transactional, if it doesn't make it to yours, the whole method gets rolled back, money gets put back into my account, things get
Oh,
undone. So,
right. Okay, so it just resolves any sort of conflictions. I totally
basically,
understand.
basically.
And now how okay, you
It's
can't do one
basically
spread it.
yeah, it's basically a proxy feature, and it's not a language feature. So like so it doesn't actually see the internal methods, but it does happen to know if thanks to Spring 7, if you have a private method, it doesn't see it. The transactional annotation does not recognize it, and thus it does not work.
Ah,
Much like that, if you're in a controller, and if you're a controller or REST controller, if you have a get mapping, put mapping, whatever mapping on top of a private void or method, um, it also will not pick up on it because it's private. You'll actually get an error page.
That's interesting. You'd think that because Spring uses reflection, you'd think that
I
it would
thought
just
that it
set
didn't
itself
matter.
this modifier.
I
Yeah,
thought that it didn't
it
matter.
shouldn't matter.
And it wasn't until I actually upgraded one of my projects to Spring Boot 4. I used to call all my controller methods private because I didn't want them to be accessed from outside of their controller.
Right.
However, once I did that in the project that I was using Spring Boot 4 and Spring Framework 7, I actually had an issue and got an error page when I went to my thing, and I had to look up the reason in the documentation, and I found out that if you have a method set to private, it will actually ignore it.
That's really interesting, and I would love to know why that is. Might research into that later.
It's a really interesting fact, and it kind of bothers me because I like keeping my stuff private when it needs to be private.
Yeah, no, absolutely, I agree.
Right.
Andrew, I wanted to talk more about your fascination with compiler theory. So,
Yep.
what exactly do you like about compiler theory? Is it like, does your brain just want to optimize everything? Because I feel like that's what it is. Like, you want a better solution, a better, faster solution.
Uh, I don't think it's inherently about optimization for me. I think it's just more about linguistics and the philosophy behind just
Oh,
languages in general. Um, I really enjoy writing small compilers right now. I haven't written any big, large scale compilers, like that. But I've written some small DSL languages, which is domain specific languages, um, for those who don't know. But yeah, it's pretty much I just enjoy the idea of knowing how languages work, being able to pick up languages pretty much in an instance. And it's quite interesting how, to me personally, I feel that languages such as programming, they're very similar to how we speak languages in English, Spanish, whatever. It's very similar. There are a lot of ambiguities within the languages, just like there are a lot of ambiguities within our languages. Um, you know,
I've got
everything.
a
Sorry, go ahead.
so I've got a follow-up question for you.
Yeah.
So, I like how you say that languages should be fluid, kind of like English, right? Now, would you consider AIs like Claude Code or ChatGPT? Would that be, I know it's not actually compiling the code, but it's generating the code, but you speak to it with entirely natural English. Would that be like a pseudo sort of compiler?
I don't necessarily know that much about artificial intelligence. I know like some little bit of LLMs, like how they work, um, just from like small scale. But I don't know anything like how it works internally. Um,
No,
I don't really know if like if it's basically its own like language, because the way I think of languages is like what I see the future of programming languages is we strive for higher simplicity. And I hope that in the future languages will just be pretty much as simple as writing English sentences like do this, or you know whatever. It may even be agentic programming, but you just say what you needed to do, and then it does it in some way. Um,
Sounds
but
like
where I
vibe
think that a
coding.
lot of yeah, right. But where I think that a lot of the problem lies is that obviously because these languages are designed the way that they have their own things that they're good at and problems that they have within themselves, and that's why you use specific languages, like the old saying, if something is going to be written in JavaScript, then it's going to be written in JavaScript, right? um, or if it can be written in JavaScript, it's most likely going to be written in JavaScript, whatever the saying is. But because JavaScript pretty much runs the web, unless you're going to be writing WebAssembly, which a lot of people are not going to be doing. But just imagine a world where there's a universal language that could interopt with all these other languages. That would be the ideal language, right?
So you're
Just
thinking
like,
on the terms of Graal VM, like some polyglot language that can compile down to anything.
yeah. And I mean that's the beauty of compilers, and that's why I really enjoy compilers, is because what is really a compiler? I mean, it just turns a source code into some representation into another type of code, right? So that the computer can really understand it. It's turning your ABCs into zeros and ones for the computer to be able to read.
Yeah. So do you like we can't eradicate these languages. Like everybody is super biased and thinks that all of their languages are the best. I don't see that us having like a universal language, because obviously people have different preferences if it's statically typed, if it's functional, etc. Right? So you can't have a one language. But so I really do like your idea of like a polyglot language that compiles down to everything, like a universal language that is not a universal language. It also compiles down to all of these things. Um,
Right.
that's an interesting idea. I really like that. Is
Or
there
even
any projects that are trying to do this that you know of right now?
I mean, not necessarily. I mean, there are some like things that I've seen from Chris Latner, who created Swift, LLVM, and many other languages. He talks about how Swift has this capability of being able to run Python. And there are some problems with Python because Python 2 and Python 3 are completely different languages. Uh, and so, that's another thing where you look at Java, you have Java code from Java 1, Java 2, 3, all the way up to 8 till now 25. You can run Java 8 code on 25 as well. And so there's a lot of different things that these languages have. And yes, it would be nice to inherently have one language that can compile down to other languages. But what I think the ideal thing would be is have one language that can essentially port other languages. So you could have like maybe a language that if you wanted to get systems, embedded into it, you could essentially just maybe have a C library and then you just write C code and it can essentially compile that, and it'll also use like JavaScript code, right? But what I'm very interested in is essentially really trying to understand the web and see where the ambiguity lies in there, like in the sense of like why is JavaScript the only option and these other languages like Mint and other I don't know off the top of my head other languages, but Mint is definitely one. They compile down to JavaScript, so it's yeah, it's its own language, but it's still JavaScript at the end of the day. You know what I'm saying? So it's like I'm very interested in things like that, and that's where I hope to have my research in. We'll see though.
What's your opinion on Kotlin versus Java? Because they both use the same JVM.
Um, I think they're both good languages. I think any language on built on the JVM is a good language. I mean, I think the JVM is a solid foundation, like for as a compiler. I mean,
I like how
sorry,
JetBrains
excuse me.
I like how JetBrains was able to take the JVM and essentially rewrite Java in a modern syntax, um, or way. Um, but I love that it's run on the same JVM and essentially boils down to the same thing.
Yeah, yeah. I mean, you have Scala as well, um, and pretty sure. I don't think what's the other language? And there's another functional language as well that's also on the JVM, that's heavily used. But yeah, it's awesome what you can do, and you can even write Java in Scala as well, and that other functional language. But it's crazy how the JVM you can just really interrupt with any language like Kotlin, Java, and just jump
Mhm.
in between.
I've never actually written Scala. I've seen a little bit of it, but I've never actually bothered to touch it.
Yeah. Let me see what the language is, right? So obviously Groovy, Clojure, that's what it is, Clojure. That's the other functional language. Kind of crazy how I forgot that. But yeah.
Can't say I've written in
Yeah.
Clojure either.
I can't say I have either.
You don't want to write in Clojure. It's not nice. It's not pretty. It's super functional. It's extremely functional
Mm.
to a
Yeah.
fault.
What
But I
is you?
think that,
Go
go
ahead.
ahead, sorry.
No, go ahead.
No, I don't want to go on too much of a tangent, but I did finish, like I was talking to you about this, I think a few weeks ago, but when I finished my classes last semester, I learned a lot in my theory of computation class, and just it's really crazy. That was probably one of my favorite classes of all time, because it's crazy how these things that people are studying within like the theory, it's heavily used, and like it's really not that compilers aren't really as difficult as it seems because it's very concrete. I mean, yes, it is very difficult in retrospect of like, that's a bold claim saying that it's not difficult because it is, but um, in the sense of like how it's designed and how you want to design things. Like you have S expressions or S parsing, which is like list-based languages. Um, and that's just a sort of way that parse trees do it. And then you have other languages like Java, which derive from C, which derive from lower type of styled programming, which is more imperative and more Turing machine based. So these style of theoretical computation, they do very much relate and translate over to the realities of what we program in today. It is crazy too.
Mm.
Just how I've been making that connection within the studies.
I
It's
like that. I like that analogy. Like, so you're saying that one feature is based on another. So you start with basic CPU instructions, right? Then you can write like x86 assembly, which is how the first C compiler was made. Then with the C compiler, you made the Java compiler, and then with the Java compiler, you could maybe do something with like LLMs. Like it's a progression, right? So you went from something that was super rudimentary to
yeah,
something more fluid and
I mean,
abstract.
if you dated back
So
right.
far, you dated back far enough, old compilers were
that's
manually
right. Yeah,
done.
the plugs. Yeah, you would replug like connections in your computer. So I forgot about that step
Yeah,
entirely.
if you
But
date it back far enough. But that's
so
also
what's the
I hear
progression?
I hear that that's also a fault in compilers is that they're built on technically like their own languages or like themselves, and it all dates back to the first human that did it, and that like at the first human built this compiler, then that compiler essentially led to the next one, to the next one, to the next one. But I heard that there's like a slight fault in like all compilers that dates back to the original human input. But I don't know compilers enough to know it. I just read it in an article one day on Wired.
Yeah.
I wonder what the next progression is. Because now we have these abstract functional languages. What's after that? What's after functional languages? Does it go to natural language processing? Like you said earlier, you write your code in English or whichever language you're proficient in, and then is there anything beyond that? Is there anything beyond that? Like maybe it'll connect to our Neuralinks and we just think about something and it'll code it for us.
Yeah, that'd be crazy, right?
That's Elon
Yeah,
Musk's new next thing.
yeah. I mean, I'm very optimistic with a lot of things, and it would be really interesting to say that that would be a reality, but um, who knows? I mean, who knows? I mean, you think about the problems like you were saying earlier, like we went from C to the abstract, the higher abstraction, but we think about the problems that they were trying to solve at the time that those were existing. So why C became a language and what problems did C have? I mean, it was only x86, so you had to write it on different you had to write the same software for different style of computer with that language to be able to get to get it to run on your computer, whereas Java is you write one and it's used everywhere, right? And so they solved these different problems and that's the beauty of compilation as well, because they do deeper research into, how can we solve this sort of problem, and it's some in some way compilation is very close to the hardware as well. So there are a lot of hardware problems that they think about, and they're trying to figure out how to optimize at the end of the day. Like on the back end, there's a lot of like, how can we, solve specific problems? Like how can we optimize for signed integers or unsigned integers, and what's a fast way? Can we do a two's complement? Should we do a ripple carry versus whatever? That's just one little small thing that people think about probably within their compilation. That's something I would have to think about when it comes to integers, because integers are obviously a big problem within compilation. Um, it's trivial at this point. Like it's trivial in the sense of how we would create a language with integers and different types. Actually, types are a great thing. So in like mathematics, you have type theory, and that's in category theory. Those are like the big thing that's starting to come about within the last, I would say, 10 years. And they're seeing a lot of significance with type theory, or relevance with type theory and category theory with types and programs. Because I mean, if you think about, you know, I don't know if you know what type theory is, but essentially it's a sort of like it's based off lambda calculus as well. Well, it's not based off lambda calculus, but it has lambda calculus. It has typed lambda calculus as well. And it solves a lot of problems, and it has a lot of questions and problems that we are still worrying about this day. Like types are very much a problem within languages, and we try to figure out how can we invoke types with an abstract way. Like Python, it doesn't have types, and so there can be, I mean, it does, but under the hood, you don't have to use it, right? Um, and there's a lot of problems with that, because you can have an application that has 100,000 lines of code and you don't really know what type is what when you're working with things, because it's very abstracted. So there's a lot of problems that, sorry, go ahead.
So I was going to say, because so when you said that people were trying to solve a problem, that's how languages evolved. They were trying to solve a problem, then they found another problem, and they created a new language to solve those problems, right?
Right.
But I think with each iteration, you're also creating problems as well. Like when you
Yeah.
abstract it, like for instance, Java runs on the JVM, which is written in C. In C, you have these low-level features where you can directly interact with the operating system, whereas in Java, you cannot. So
Yeah.
I think with every new iteration of trying to solve a problem, you create a couple more. I don't know if it's equal uh, or not, um, but you're still creating some sort of flaw.
Yeah, one thing I think about too is like, I mean, like when you think about C and Java, like you have garbage collection compared to, having actual hands-on to the memory, and having access to the heap and having access to your stack. Um, and there are obviously some trade-offs with performance with that, but we don't inherently care about performance in this day and age, because performance is such a trivial thing because we have so much performance now.
You can just throw more hardware at it.
Exactly. We talked about before how JavaScript, or, the JavaScript and TypeScript, they're very much, it's single threaded, and there are also some problems within the language because it's quote unquote slow to a lot of people, but it's actually pretty trivial. You look at a lot of applications and they're written in TypeScript or they're written in JavaScript, and that's because, a lot of modern computers can run that at speed. Um, and it's crazy, yeah.
Is there a point in which we should start caring about optimizations again? Because from what I remember, you used to be able to fit a whole game in 50 megabytes, like a really nice game in 50 megabytes, right?
Like
Now, Call
Mario.
of Duty, for example, yeah, exactly. And now Call of Duty is shipping without any optimizations whatsoever with 120 gigabytes per game, right? And our hardware limitations, like they are progressing, but with diminishing returns. So we're only able to throw so much hardware at it And I feel like
I
that
will
we're not.
not to cut you off. I'll be right back in a second.
Mhm. So I feel like we can only throw so much hardware at it before we need to start optimizing again.
Yeah, I think that that also that problem is from just the bloat from the engines that people are using. And obviously because we want more high definition, we want better quality in games. So yeah, it's going to be more gigabytes in data. And yes, I think optimization is very important. Um, but I think that a lot of people don't inherently care. They don't have to care because it's so trivial.
Right.
Because yeah.
So, do you think there's going to be a point where like we come full circle, we come absolutely full circle, and like our hardware limitations are restricting us? Like our hardware will be the bottleneck. Right now, our hardware is definitely not the bottleneck. But do you think there will be a point where the hardware will become bottleneck, and then we'll have to start micro optimizing things again at like a very uh micro level?
Mm, that's a Windows writing taskbar in React, really? Speaking of bloat, I don't really think I understand the question that you were trying to say though. Sorry about that.
So Moore's law.
Yeah.
Are you familiar with Moore's law?
Yep. Yeah. Yep. A
So
double. Yep.
yeah, exactly. The microtransistors on CPUs doubled every 2 years. And that law held up true for a really long time.
Yep.
Up until I think like 2013-ish is when it started diminishing, and we weren't seeing like the doubling of hardware every other 2 years. And now we're kind of hitting a plateau in which the transistors on CPUs are at the micron level. So we're not able to really fit Moore's law anymore because we're not able to double it. And so like we need to we're trying to like we're trying to wring out all of the optimizations that we possibly can in our hardware. So when people stop caring more and more about the optimizations of their software, and we're getting more restricted in our hardware limitations, do you think we're going to revert back to um, like just optimizing every little thing, like caring about everything, and I mean absolutely everything?
So I think that that's a good question, and I think that a lot of languages, if you look at languages like Go, and so Go has coroutines, right? And what is coroutines is basically just allows you to do pretty much multi-threading. Java has this as well. You're able to have threads, and I think that yes, Moore's law may not be true now because it's so small at the scale of the hardware, to the point maybe it can't get any smaller, but who knows? Anything's possible. Um, but with respect to hardware, if you look at CPUs and stuff like that, they're getting more cores. And so that the more cores are allowing them to have more threads and doing more multi-threading. And with this multi-threading, we're allowed to have more computability, more computational power. And I think that that's the direction that we're going to see hardware go with. They're going to have more cores. Like if you look at how the cores are now back then from 5 years, I mean, I have an i5. I think it's an i5 900K or something like that, but it only has, I think, like 4 cores. And if you look at the i5s now, they probably have like maybe 10, 12 cores. So or maybe not that
Yeah,
much, but
I've got a Ryzen myself. A Ryzen. Wow. Uh, Ryzen 9. I've got 16, but I mean Hyperthread. That's 32. Pretty fucking good.
yeah, yeah. I mean, if
I
you
can I
like,
can
I'm gonna
remember
look it up how many cores.
I can remember my first
And yeah, an
my
i5 has 14 cores, and I have like 4. That's crazy. That's a crazy
mm,
difference, and that's still an i5 model.
yeah, that's wild.
So, and that
One
allows, sorry, go ahead.
No, you continue, please.
No, I was just gonna say, and that just allows for more computability when with threads. So you can actually, so I think multi-threading is something that languages are also going to do more interest in, because I think that uh, there's a lot to be done with multi-threading, and obviously I think with multi-threading you can have race conditions and stuff like that, right? That's where race conditions lie,
Hmm.
and other things like that. So there are problems within that as well, but yeah, I think that with having more cores, yeah.
I was going to give you guys a fun fact about CPUs.
Let's
So
hit it.
when they manufacture CPUs, the amount of cores that a CPU has, especially the lower ones, is due to a fault in the CPU. So they try to manufacture them with as many cores as possible, because the more cores it has, the more valuable that CPU is, right? And so when they have faulty cores, they actually just put it in the lesser core pile, even though they were every single CPU manufactured was supposed to have as many cores as possible. So if you had 32 cores in a CPU, you got really lucky because that CPU came out perfect. If you had 5 cores in your CPU, it was intended to be a 32 core CPU, but it so happens that only 5 of those cores were actually working.
Interesting.
That's crazy.
Interesting.
Yeah, silicon is super expensive, and the machinery behind these manufacturing plants is really, really expensive.
I bet.
So they want to push out as much money as absolutely freaking possible.
Yeah.
Now, I've got a whole demonstration of Java things to show you guys.
Hell yeah, let's go for it.
Okay, I'm so excited to share this with you guys.
Share the
So
screen and take a look.
I'm sharing now.
Yes, I'm
So
watching.
I'm not going to do this. I'm not going to do this in any particular order.
I am just
Um,
going to say this for our viewers. Do you mind hitting Alt Shift plus a time or two?
Alt, yep. Alt Shift plus. Oh, little laggy. There we go.
Mm,
How's that?
I hope that's okay for our viewers. Anybody watching
I'll
right
do it.
now? I personally
I'll do it
usually
one more time.
I do mine at 175%, but I mean 150 looks pretty good to me.
Okay. So there's a wise man in our Discord community named Sentryman, and I'm going to do a quick impersonation of him. And he says, "Have you ever heard of the arrow notation?
Oh
Have you
gosh.
guys ever heard of the arrow notation in Java?"
I have not.
So this is entirely satire. There's no such thing as an arrow notation in Java.
Love it.
However, when you are initializing a for loop, right, and you want to iterate backwards, if you do int I is equal to your maximum number, and then you do I heads towards 0, it'll loop. So if I run this, it'll do 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And essentially, this looks like an arrow, but what you're doing is I minus minus is greater than 0. So here you have your initializer, and then you subtract from I, and you check if it's greater than 0. But it looks like when you have it formatted like this, instead of this, it looks like I is heading towards 0.
That's a neat little trick. I
Yeah,
like
that
how
So
is.
it.
stupid. It's not neat. You shouldn't ever use this in production. It's
I
just
I
it's
think it's
quirky
neat.
and funny.
I think it's neat in that way that you would say something to a child that does something cute.
Absolutely. I agree. So here's another one. Dividing by 0. So in Java, what do you expect this to do right here?
Throw a conniption fit.
That's right. So in Java, if I run this, I will get an arithmetic exception.
Mm-hmm.
You
I would hope
cannot
so.
divide by 0.
Yep.
However, If I change this type to a float and I divide 1.0 divided by 0, I
Yeah, that
no
makes sense.
longer get an arithmetic exception. I
That
now
makes
get
sense.
infinity.
Yeah, that makes sense.
That's hilarious. I love it.
That's you know what that has to do with, right?
Yeah, it's the mantissa. So
Yep.
because of the mantissa, you have one extra bit. You have one
Yep.
extra bit that you can use to store infinity in.
Yep. 100%. That shit's awesome.
Okay, I have a couple more for you.
I'm curious about
So
that cafe baby. That's that one you were talking to me
I
about.
will get. That's going to be my. That's my favorite one.
Okay,
That's my
so that's
favorite one.
so by default that's the last one. Damn.
I think so. So const and goto in Java are reserved keywords. They're
Yep.
reserved keywords, but they do not do anything at all.
That's because they were planned to be go-to was planned to be a feature inside of loops so that you could break free from one loop and go to a next
Yep.
portion. But it never actually got its way there. Similar
And-
things that most people don't use is label in a for loop.
And const, I would assume that meant it was like var for immutable objects.
Honestly, const, I have no idea. I have no idea of. I didn't actually know that was actually a keyword in Java, to be honest with you. I thought that was a keyword in other languages.
Now, speaking of keywords, do you know what is not a keyword?
What?
Var. So, you know how you have like var I is equal to 1, right?
Mm-hmm.
Now, var is a reserved key, or sorry, it's not, int is a reserved keyword. So if I did like int is equal to 1, I can't do that. I can't name my variable int because it's a reserved keyword.
Okay.
Var is not a reserved keyword. It is highlighted as a reserved keyword,
Huh.
but I can also name my variable var, and it compiles just fine.
Oh, that's so confusing. Now, how would you if you go to? Okay, no, that makes sense. Interesting. I like these facts.
Yeah.
So, oh my gosh, I want to click on Cafe Babe so badly.
Nope, you got to tease me first. Tease me with it.
Integer represent. So you're familiar. So you can represent an integer by its literal value. Did you know that you can add underscores to your values?
Yes, sir. I use them all the time to represent 6-digit figures, so to speak.
I do sometimes. I honestly I forget about it a lot, so I don't. And then you can use 0x. You can prefix your integer with 0x to represent it as hexadecimal.
Yes, sir.
And then you can also prefix it with 0b to represent it in binary.
Mm-hmm.
Yes, sir.
I did know that.
So if I hit play, this is going to print 1010 because this is the decimal system we use. This here is also going to be 1010. This is going to be different. I can't remember what the number is in hexadecimal. And then this should be 1, 2, 4, 8. So 2 plus 8 is 10. So the last D should be equal to 10.
Got a whole bunch of 10s going on.
Oops.
I was gonna say you ran the wrong thing.
Yeah. So we have 1010, 1010, and then 1010 in hexadecimal is 4112, and 10 in binary. I already showed you that. This one is really neat. So if you have a anonymous object in Java, I've initialized inside of this object an integer called foo. If I want to reference foo in Java, I can't. It's not here. If I do int.foo is equal to 2, for example, doesn't compile. It can't recognize foo. But if I change object into a var,
Now hover over object for a second. It is still no the other object. Yeah, it is still an object, which is
it's still an object. But when it inferences the type, it's also able to inference more information on the type.
actually kind of interesting.
Okay.
This one here. So you can actually use any Unicode character as your variable name. As long as it's Unicode compliant. Doesn't actually matter. It doesn't have to be in English characters. It can be whatever you want. So,
Oh, wow.
So people can write in Chinese, for example, using Chinese characters here. It all compiles, and you can run it just fine. So here I'm printing out the floating point number for pi, and Java is equal to true, and it works just fine. Now, as a little hidden Easter egg, do you see this line right here?
Are you closing the comment?
No.
Or escaping the comment?
I'm escaping the comment. Good observation. So you can't actually see it in IntelliJ, but I have a comment right here, which should render this line entirely useless. Right? But the /u000d is a new line sequence.
Okay,
so
so it's making a whole new line theoretically and placing system out print on a whole new line.
Yes, exactly.
Ah.
So if I go to here, if I go to an online editor and I paste it, you can see that this bit of code actually looks like it's commented out. Right? But if I run it, actually, maybe that did, I don't know why that didn't work. Oh no,
yeah,
it did work.
It did work.
There we go. It prints out the expected output. But it looks like it's commented out because this character is to comment out this line, but then this character right here puts the rest of the code that precedes it on a new line.
I feel like that's a hack waiting to happen.
No, so IntelliJ is clever enough to actually detect that, and it doesn't look like it's commented out. However, in previous versions of IntelliJ and most other IDEs, this line of code here would look like it was commented out.
That's actually pretty cool. I like that piece.
That is cool.
Here. I can't remember if I showed this or not, but in a array literal, you can have a trailing comma at the end and it will still compile.
I did know that because I've left commas in there accidentally and it still worked.
I didn't know this until today.
I only knew that because I goofed up and did it myself.
Now.
Cafe baby.
Cafe babe. Cafe babe. I'm gonna zoom out once. Oops, I didn't mean to do that. Was it Control Alt minus?
Nope. Control. No, it's Alt Shift.
Alt. Okay.
There you go. Now you got to do a Control Shift plus to expand everything.
And what if I just Control Shift plus?
There you go.
Yeah, awesome. Okay, so I have a class file, right? Any class file will do. I'm reading in all of the bytes of the class file, and essentially I'm reading in the first 32 bits of the class file.
Okay.
So right here, I'm iterating over it 4 times because there's 4 bytes in an int, and then I'm reading in the byte and I'm storing it in the rightmost portion of the int and then shifting it over. And then when I read in the next byte, I shift over the rest of the data and then store the byte in the rightmost portion of the integer as well. So it's taking the first 4 bytes and it's storing it inside of this integer. Okay. This is the file format of the class file. Now, when I run this, the first 32 bits of the class file are minus 8892757714. Nothing particularly interesting about that. However, when you represent it as hexadecimal to hex string,
Does it print out the file or?
oh, sorry, no, that was 2 binary string. My bad, sorry. If I represent the first 32 bits of the file as a hex string, it prints out Cafe Babe.
That's cool.
The first 32 bits of the class file header in Java is hexadecimal Cafe Babe because they are all legitimate hexadecimal characters. 0x Cafe Babe. And you could even store this as an integer. Int cafe is equal to Cafe Babe.
That's funny as shit.
That's actually interesting as hell.
So
I didn't-
so Cafe Babe is actually like the first for Java you said?
Yeah, for
That's
Java
a-
class files specifically. I
That's the
don't think it's the header for jar files.
That
It's
is
for class files.
hilarious. That's hilarious. I love it. And I did not know that.
And that concludes my tips. Not tips, my fun facts.
There we go. All right, viewers, if you learned some new facts, hit that like button. I want to hit that like button because I like those facts. So now, with your day-to-day work or your day-to-day studies, what is a tool that you cannot live without?
Vim.
Why did I see that coming?
No!
I saw that coming.
For the viewers, can you please tell us what is so good about Vim? Can you convince me? I want to be convinced because I've seen an insurgence of Vim users, and I want to know why.
My honest opinion is you can't really convince someone to do Vim because it is, if you really want to get good at it, it's sufferable. Like it's just it's gonna suck for the first few months, but after a while, just like a lot of things, it gets better and then it gets amazing. And the reason why I love using Vim is because it feels like I'm playing a game every day. So I've gamified my programming experience.
Ooh, that's a nice way to do it. I just don't know if I can get behind that game. I become so reliant and so comfortable with my IntelliJ that, oh, I don't know if I
feel
could.
like it's a quick way to arthritis.
Yes.
Arthritis? That's why you get a split keyboard, man. That's why every Vimmer you know has a split keyboard.
Do they actually?
That is
I mean,
hilarious.
A good
He would
amount of
keep
them.
no keyboard if he could.
They'll saw it in half.
Mm. That's hilarious.
Are there any actual like practical applications of Vim? Is there anything that's quicker to do in Vim than in a traditional IDE?
I think that there's Vim has a great ecosystem, especially NeoVim, because it takes Vim script and it brings it into Lua and just all the capabilities that you can essentially have an IDE if you want in NeoVim because it can do all the things that modern IDEs can do. It can do. I don't think it has a debugger, but I'm sure you can find debuggers. Some people build plugins all the time for a bunch of stuff. So I think NeoVim's incredible. It has a great ecosystem and has great contributors.
Is there anything that you have found quite tedious when clicking on a GUI that is absolutely trivial in Vim?
I think just searching files, in my opinion, is just fast as hell.
Yeah,
It's just
I
a
can
mess.
imagine.
Yeah,
Yeah,
I'm
it's
pretty quick with my searches too. I hit that double shift button and it brings up a search everywhere.
I was gonna say that same thing. I wasn't gonna say it, but I wanted to say it, but I wasn't gonna.
Hey,
I'm just saying,
I,
like,
I push IntelliJ, man. Okay, I preach it. I push it. I think everybody should use it. That's my
yeah,
opinion.
I don't think that any IDE matters. Honestly, I think the code matters, but I think that the reason why I really love Vim is because I can use any language. I don't inherently need to use a specific IDE for a language. I can just use Vim for every single language that I want to use, and I get the same
Now,
crappy
That
GUI
comes.
that I
do
have.
would you have to like install any kind of interpreter or compiler or like SDK with each? Say, if I wanted to go from like Python to Java to C to like, is there any? Is it just out of the box good to go, or do I have to download any kind of plugins, features, or like what?
There's a common plugin that people use called Mason. It's just an LSP, pretty much handles all the LSP plugin and Tree Sitter as well for syntax highlighting. Um, and pretty much what you would just do is you would just pull up. I mean, I can show you real quick too as well.
I would love to see a demonstration. Yeah.
Sure, let's go. Whoa!
So, I mean, if I'm, you know, let's just say we're not on Vim, and we're about to go into Vim. Uh, if I wanted to install C or something, I would go into Mason. Mason is just an open source plugin that you can download. And how you download it, I use a package manager called Lazy. So all I need to do is just create the file. Like if I come over here to Mason, and then I just return this, whatever, this, and this is his branch. So Lazy does all the stuff under the hood. I don't need to worry about it. I just create the files, and Lazy does the rest for me. Great package manager. That wasn't an ad, by the way, but no, I'm just kidding. But yeah, let's just say hypothetically, if I wanted to install a language, I already have C, and I have Java. So these are just LSPs, language server protocols. If you don't understand what that means, that's okay. That's pretty much the syntax highlighting, and go-to definitions and all that cool stuff that you get with these modern features with IDEs and stuff. And so that's basically what this is. A lot of them are open source. JDTLS is the Eclipse one. And there's other ones like Java Language Server. I'm pretty sure this is Red Hat. But yeah, so you could see that all I need to do is in here, I would just look for like Lua, and then I would search and look for ones that say like Lua, and then I would just install this one, and I have LSP built in, and it's as easy as that.
Hmm.
I
And
like that. It's kind of like a polyglot IDE in a way, and you're relying on community source plugins for support from each language.
yeah, yeah. And I have modern features like syntax highlighting. I have, if I wanted to check this out, I can just hover over this and hit man, and I have the man pages for C, and I can look at the standard library.
I'm
Are
still
you using?
I'm still looking at your int main.
Are
Oh,
you
it did.
using Vim from your terminal? Or
Yeah.
is this some sort of okay, awesome? Because I know there's an implementation of Vim that has a GUI.
I've haven't used that. Like the one that you can download onto your desktop, and
Yeah,
then
yeah.
so that's still utilizing a terminal, like it's still like terminal based, but yeah, it is its own little application.
Okay. I think I've seen applications that have like a terminal inside of the application.
Yeah, I'm pretty sure that that one that you download too is also terminal based, but I think it's just a like an extension. I think it's like an extension link, and it just automatically runs on the back end, like the bash scripts to run NeoVim.
So what's the difference in between Vim and NeoVim? I know you said NeoVim has support for Lua, but is there any other fundamental difference, or is it just the Lua scripting?
Yeah, Vim's maintained by one person. I forget his name. I think his name's like Brad or something, but I don't want to botch it. But Vim itself, if you can look it up on GitHub, it's maintained by one person, and NeoVim is an ecosystem maintained by multiple people. So pretty much his name's Chris Bra. That's the guy who, so anytime anyone tries to make a pull request, it has to go through this guy, Crispra, and he approves it, and that's for Vim. But NeoVim is kind of like a collective thing where people make decisions on what gets done.
Does
Okay.
NeoVim still currently rely on pushes from Vim?
No, it's a totally separate ecosystem.
Okay, so
fork.
it was inspired
Fork.
by, but no longer is reliant on Vim.
Yeah, it's a fork of Vim. Yeah, yeah.
Okay.
Well, I know, so it's a fork, but do they ever pull from the Vim repository, or have they totally diverged?
Yep, they've diverged. I believe they've diverged 100%.
Okay, I gotcha.
Yeah, because yeah, they have. I mean, they're still. If you look at the commits too, as well, like NeoVim has 34,000 compared to Vim's. I think it's like 22,000.
Which,
So
you know
NeoVim,
what,
they're
is
cooking.
really impressive from an indie developer as opposed to a community.
Yeah,
That's pretty impressive.
yeah. Well, a lot of times people are making pull requests, but he's the one who's ultimately just committing everything and merging everything.
Right.
Yeah.
Hmm.
So yeah, it is crazy. He's reviewed pretty much all those 22,000 that have been merged.
That's pretty wild.
Yeah. It's incredible though, like how they've built a text editor so simple that's made it through the times. Because Vim came from Vi, which Vi came in, I believe, in the early 90s, and I'm almost certain was in every Unix system, automatically.
I feel like that was a DOS based thing, wasn't it?
I'm not too sure. I don't remember off the top of my head.
Sounds
It positive. I remember having Vi
sounds
in
familiar.
Linux.
Was that mine or was that?
I was gonna
I
say
heard somebody's Discord go off. I don't know.
it wasn't mine. I heard it too, and I had to double check, but it wasn't mine.
It wasn't mine, I don't think.
Must have been mine.
I keep mine pretty clean, so I've got no messages here. I know I keep it pretty clean because otherwise my OCD starts twitching.
Mm.
My Discord is so messy. Oh my gosh.
Yeah, I've got all.
Very
I've got my guilds put in folders. Like the most common guilds I have those Oaten person, and then like I've got pretty much everything like the important shit I have turned on, like at like notification channels or at announcement channels. But for the most part, everything's muted because I don't want to get like 50 million spam messages in a day.
Oh, I know. I pretty much mute everything because I just can't stand the Discord anymore.
I don't even have my most important or active servers at the top. Like some of the servers that I use every day, I have to scroll down a little bit.
Oh, you gotta organize that shit, bro.
Oh
You
no.
you can drag and drop them on top of each other, and it puts them into folders.
I just don't want to. I'm lazy.
Valid. It's valid. But yeah, I mean, Any other questions that you guys have about compilers and stuff or work? Like any like
That was me.
I don't know.
Yeah, I've got a million questions, but
But
off the top of my head, I got to think about it for a second.
yeah, I
Alright.
guess we'll have to. Kind of seems like the coffee's running low, so we'll have to come up with some questions there, and we'll have you back on another episode.
Absolutely, I have really enjoyed talking with both of you guys tonight. This was awesome.
So thank you
Yeah,
very
as
much.
well.
Thank you very much, Andrew, for your time this evening, taking away from your busy schedule and hearing your opinions and your thoughts with us. If you guys have enjoyed this podcast, make sure to hit that thumbs up button and smash that subscribe button as well to be notified when we go live weekly, as well as when I post other videos during the week. As always, keep your curiosity open.